Hello, my name is Ryan Cassida. Question I am going to answer is, how are exoplanets discovered, and how do we collect information on them, such as the planet's composition? First, let's ask the question, what is an exoplanet? An exoplanet is a planetary body that is outside the solar system, and that usually orbits a star other than the Sun. For the sake of time, I will only go over three detection methods. The first method that we will discuss is the transit method, and it is the most successful. When an exoplanet orbiting a star passes between the star and the observer, the star appears to slightly dim. We can use this method to detect a planet's size and the orbit by measuring the magnitude of the drop in brightness, as well as the time of the event. We can even determine a planet's atmospheric composition using the light that passes through its atmosphere from the star to the observer. The problem with this method is that the observer must be perfectly aligned with the exoplanet's orbit. Also, false positives from binary star systems are common. The next method is the radial velocity method or Doppler method. As we learned already, when two celestial bodies orbit each other, they orbit around a fixed point between them, which is their center of mass. When a lower mass exoplanet orbits a star, it can cause the star to appear to wobble. The Doppler effect works when an object emitting waves is moving, and when the object approaches the observer, they will observe a higher frequency wave, and when the object moves away from the observer, they observe a lower frequency wave. In our case, the waves are light. When the star rotates away from the observer, we see a redshift. When the star rotates towards the observer, we experience blue shift. We can use this to tell if a star is under the influence of an exoplanet. The last method is gravitational microlensing. Gravitational microlensing works when an exoplanet passes between a star and the observer. Gravity causes the light from the star to bend around the exoplanet and act as a magnifying glass and make the star appear brighter to the observer for a short period of time. This is helpful for spotting rogue planets, which are planets that do not orbit stars and instead roam relatively freely. The problem with this method is that it requires the star, planet, and observer to be aligned perfectly. In conclusion, the three methods we looked at was the transit method, where we can detect exoplanets from the dimming of the star it orbits, and even detect its atmospheric composition. The radial velocity method is where we can detect exoplanets by observing red and blue shifts from changing wave frequencies. Last was the microlensing method, which detects exoplanets by observing the increase of brightness of a star from an exoplanet's gravity, magnifying the light. Here are my resources. Thank you.